This is a solar inverter. This is a breaker panel powered by the solar inverter. This is the grid. This is a breaker panel powered by the grid. This is a transfer switch, which allows you to choose between the grid and the solar inverter. In this video, we're going to show you how to make them all play nicely together. This video is part 3 of a series, and it builds on the information from the first 2 videos. Part 1 covered the basics such as bonded neutral, floating neutral, earth ground, equipment ground, and more. Part 2 was about grounding and bonding an off-grid system. Now there's a link for the whole series up in the upper right. I'll also put a link down below in the description. Okay, so let's design a system that uses AC from the grid as an input. This is known as grid assisted. It is not the same as grid tied, which means you can sell power back to the utility company. But we can use the grid for several reasons. We can run loads when our battery is low. We can charge the battery with the grid power. We can use the inverter as an uninterruptible power system. In other words, run the loads on the grid power most of the time with a battery backup just for power outages. Now, one of the things that makes this whole subject so confusing is that there are hundreds of inverter brands, and they use different internal bonding systems. There's little or no documentation with most of these inverters about how to handle grounding and bonding. Overall, though, there are 3 main types of bonding systems found in inverters. The first one is called dynamic bonding. Okay, here's our main service panel, the inverter. And we have a breaker panel, which is a separate breaker panel feeding its own outlets, not the existing house outlets. We'll get into that a little bit later. So from the grid, we're going to go through our main service panel first. We also have our ground, which is connected to our grounding electrode, also known as the grounding rod outside. And the neutral and the ground buses are bonded together in the main service panel. So now we're going to feed power from the main service panel over to the end of the inverter. So we're going to just send a line 1 and a neutral and also the grounds. Then we're going to come out of the inverter with a line 1, the neutral, and the ground and feed our breaker panel. That breaker panel is not bonded because we already have our bond over on the main panel. And again, our rule is we can only have one bond in our system. This circle represents the inverter circuits where the 120 volts is produced by the inverter. The input and the output of the ground are always connected together, I believe, on just about every inverter, if not all of them. The line 1 and the neutral, however, have to go through an automatic transfer switch or a relay that's going to switch them back and forth between grid mode and inverter mode. When we are in grid powered mode, the line 1 and the neutral are basically just passed through, but line 1 and the neutral are going through the transfer switch, which you can program inside of most inverters. For example, when your battery gets low, it switches to the grid. This is the dynamic bonding circuit. This is also part of the relay that is going to switch as we go between grid powered and inverter powered. Right now, this is not connected, it's open. We already have our bond in the main service panel. Okay, so now let's switch this from grid powered to inverter power. And you'll notice that what happened is the relay switched our outputs. So now line 1 and the neutral are coming from the inverter and not from the grid anymore. We have created a bond in the inverter itself. Okay, so remember from the first 2 videos, rule number 1, there can only be one neutral ground bond. And now we're going to add on to that. There can only be one neutral ground bond at a time. So there can be more than one ground bond, and it can change, but only one can be active at a time. Also remember, electricity always tries to return to the source. Okay, when we're in grid mode, our source is, of course, the grid, and our bond is in the main service panel, which would take a ground fault and return it back to the grid. But in inverter mode, we have created a new neutral ground bond that's in the inverter. The source is now the inverter circuits. It's not the grid anymore. So let's see what happens when there's a ground fault. Okay, so the electricity comes out the inverter circuit on line 1, comes over here to the inverter breaker panel, and then goes to whatever the load is. Let's say it's a toaster, and it has shorted out, or rather has a ground fault. So that line 1, the hot, is now touching the case of the toaster. So it's going to follow the equipment grounding conductor, or the ground wire, back down here to the ground bus, and come over to here in the inverter, where it's going to use this bond to get back to the source, which is now the neutral of this inverter. The energy is going to complete the circuit and trip this breaker, thereby deactivating the circuit and making everything safe again. Just to keep our bearings here, this was the first bonding configuration that we were calling dynamic bonding. Technically, it's switched neutral dynamic bonding. And it is the most common system that you're going to find in all-in-ones and charger inverters. And it's good with this configuration, which is a single inverter in its own separate breaker panel. And you can use it depending on how you set the inverter up. You can use it as a solar power system with grid backup, or a grid powered system with battery backup, also known as a UPS. However, if you want to stack multiple inverters, each inverter would then be dynamically bonded. So you'd have multiple bonds going at the same time. We'll look at a better way to do that in just a minute. And dynamic bonding systems are also great for mobile systems like an RV, a van, or a boat, where you can switch between battery and grid power, which they also call shore power. Okay, now some of the brands that use dynamic bonding, well, one is Victron, which is basically for mobile, RV, or a boat. And they're actually one of the few companies that does a great job of documenting the dynamic bonding that's going on inside. But you'll also find dynamic bonding in a lot of MPP solar, some Grow Watts, some EG4s, and many other brands. All right, so that's dynamic bonding. Now let's look at the next system, no bonding. Okay, so this will also use the automatic transfer switch to switch line 1 and the neutral. But down here in our dynamic bonding system, if you remove a screw on some inverters, then you can lose your bond here. And in some cases, there's just no bond built into the inverter at all. Okay, so let's bring that dynamic bonding circuit back just for the demo. And now we're going to go to what this is like in grid powered. We're basically passing line 1, neutral, and ground straight through again. And the bond is in the main service panel. Now, when we switch to inverter power, you notice that there is no bond. One way to make this system work, unfortunately, only applies to the Grow Watt SPF 3000. You only use this method if your Grow Watt is unbonded. Some of them are bonded. See video 2 in this series to find out how to test your Grow Watt and see if it's bonded or not. If it's unbonded, Grow Watt says you can do this. You can connect the neutral in of the inverter to the neutral out of the inverter. And no matter what mode you're in, whether you're in grid mode or inverter mode, you are always seeing the ground neutral bond over in the main service panel. Now, again, this is only for the Grow Watt 3000. This may not be supported by other inverters, and it could even cause damage. In fact, MPP Solar specifically says never connect the input and the output neutral. A great use of these inverters that are not bonded is to use them when you want to stack multiple inverters. And in this case, we're going to put them in parallel mode at 120 volts. We're also assuming that there's no AC input coming into these inverters. We hook line 1 to our breaker panel, and this is a separate breaker panel. It's not tied to your house wiring. We also hook up the 2 neutrals to the neutral bus in the breaker panel. Same thing with the grounds. We can come over here now and bond our neutral in the breaker panel, and we only have our one bond. We would also add our ground rod here. Now, if we wanted to do this in split phase mode, it's almost the same thing. The only difference is we take line 1 from one inverter and line 2 from the other inverter. Of course, you have to put your inverters in the proper programming, and you run your communication cables and so forth. Okay, so our bonding configurations so far were dynamic bonding and no bonding. Our next one is going to be called common neutral. Common neutral bonding. This is my favorite by far. I hope this is the future of how inverter bonding is done. Basically, your neutral in and your neutral out are hardwired. They're always connected. When you are in grid-powered mode, you're using the bond over in the main service panel. When you're in inverter mode, you're still using the bond over in the main service panel. Makes things so much simpler. You don't have to bond anywhere else. You don't need dynamic bonding. You can use a simple transfer switch. Do anything you want after this. The only time you would ever change anything is if you're off grid. And in that case, through the software of the inverter, you can add a bond. And this bond is it's not dynamic. It's either on or off. You would only have this if you're building an off-grid system. However, for everybody else, the simplicity of always using your main service panel just is going to be wonderful. Now, common neutral has been available in high-end inverters, things like Magnums and Solarcs and so forth. But EG4 just released this 6000 XP. This is November of 2023. And it uses common neutral wiring, just like its big brother, the 18K. Of course, the 18K has been around for a while. I have a video on the Reliance Transfer Switch. I'll put a link to that, and you can check that out if you're interested. Now, this is your main service panel, and those are always bonded. Notice that we're coming off this breaker and feeding the load. So let's add in our inverter and the transfer switch. And we're going to take that cable, our hot line that's coming from the breaker and feeding the load. We're going to move it to the transfer switch. And we're going to add a new cable in that goes from the other point on the transfer switch to the breaker. And this now allows us to switch back and forth. Right now we're on the inverter, and over here we're powering from the grid. And you have a switch up here where you can select between the grid. When it's down, it's in grid position. In the middle, it's off. And when it goes up, it's running the solar to that same circuit. As far as bonding goes, notice the inverter cannot be bonded. And over here on the breaker panel is our bond. So you run your ground wire and your neutral wire from your inverter over to the transfer switch. And then you attach it with a wire nut to a ground and a neutral that are part of a harness that comes with the transfer switch. And that goes over to your breaker panel where you attach to your buses, and there you get your bond. Okay, so to quickly review, dynamic bonding was great for a single inverter when you want to use the grid and the inverter and have the dynamic bond take care of your bonding for you. The no bonding system of inverter is good when you want to stack multiple inverters and put your bond in the breaker panel that's after your inverter. Common neutral is the most flexible and always uses the existing bond in your main service panel. Okay, this is not covered in this video, but it was in the last grounding and bonding part 2. There are a few inverters that have a really weird bonding system. You should not try to bond them. You should not try to use them with a transfer switch. And speaking of transfer switches, we did talk about that in this video. And when using a transfer switch to power your existing household circuits, use the existing bond in your main service panel and use an inverter that is not bonded. Anyway, that's it for this one. See you in the next video.